name is Jacqueline Beinecke, and I'm happy to present to you today CLARUS, an interactive explainable AI platform for manual counterfactuals in graph neural networks. This is a project I did together with a group under Professor Andreas Holzinger from Vienna. So a lack of trust is still one of the main blockages in implementing AI as clinical decision support systems. And in recent years, explainable AI models have been implemented as sort of a solution to this problem by giving attributions to input features and basically telling you which input features are the most important in an AI model's decision making. And this is already great because it increases the transparency of the AI models, which especially for deep neural networks is very important. But these explanations also need to lead to some degree of causal understanding because, basically, if you don't understand the explanation, then it doesn't really explain anything. And so I believe the real solution are interactive explainable AI platforms where the XAI explanations are visualized directly in your data and you can understandably see them and then also interact with them by maybe removing the most important node or edge and retraining your model and gaining a better understanding and seeing the effects that has on the model. And so how does our platform work? First, you can select a data set. Currently, we have two data sets, a synthetic data set and a real-world data set. Both are graph data sets. So the real-world data set is a protein-protein interaction network data set for kidney cancer disease. And so the data set basically consists of, I think, 500 patients, so patient graphs, and the classification tasks is kidney cancer disease or no kidney cancer disease. And for this, we implemented a graph neural network, and these are especially made for graph type data. And they work similar to convolutional neural networks by aggregating the information of all nodes and edges in a neighborhood of, so after selecting the data set, you can explore the graph by selecting which graph you want to visualize and then sorting the nodes and selecting how many nodes you want to display. Because I think one graph has 1,900 nodes, and if you want to see all of them, you can't really see anything anymore. And then the nodes and edges are also colored by XAI methods, so the darker the node or the darker the edge, the more important. And currently we have 3 XAI methods implemented. So we have integrated gradients and saliency for the edge relevances and GNN explainer for the node relevances. And so after looking at the graph, looking at the explanations, maybe you're thinking, okay, is this node really the most important, or is there maybe an important interactions or an important edge missing? Then you can add or delete nodes and edges and also undo everything if you accidentally added something or deleted something. And afterwards, which is one of our, I would say, main contributions, you can retrain or predict the graph neural network. So you can, if you updated just one graph, you can do a reprediction and see, okay, does the prediction confidence drop maybe for this, or does the predicted label change if I remove the most important node? But if you changed more than one graph, you could also retrain the whole model and see if the model performs significantly worse or better based on your changes. And also, if you're unhappy with the results of your changes, you can also return to a previous state. So all graph states are saved in our backend. But if you're happy with your results and you're done with your analysis, you can then download your results by downloading your modified data and also a log file containing all the changes you made to the data and also basically the timeline of all changes you performed. So for an example, this is going through basically screenshots of our platform. So first, as I said, you can select the data set, here the Kirk data set, and then you can explore the graph. So here, here the explanations are visualized directly in red in the graph, in the platform itself. This is not done this way. You can hover over the node or the edge, and then you get shown the explanation value, so the relevance value. This is just for the example here. And yeah, so you can explore the graph, and we can see, okay, the edge between MG85 and MG83 is the most important with a relevance of 1 according to integrated gradients. And so maybe we want to check this, so see if it really is important to the GNN, and then we could select here delete edge and delete the edge between these two, and maybe see what happens to the prediction confidence if we retrain or repredict here. So doing a reprediction, we can see the prediction confidence drop from 1.73 to 1.34 after we removed the edge. So we know that there was definitely some information in this edge that was important to the model. So we have shown that that edge was important for the GNN. And now that we're happy, we can press the download results button. This does take a long time because for every graph the all explanations have to be recalculated and saved. So really just do this if you're really done, because it takes like 20 minutes to download currently. And yeah, so for future work, of course, this is a prototype and there are still many new things we would love to add, like adding additional data sets and different data types. So currently we have graph type data, but maybe allowing a user to upload his own data would be a great feature, and also different data types. So for example, tabular data, then one could change the visualization to maybe a heat map style, which for patients and features, and then have it visualized in that way. Then also adding more graph manipulations, so maybe deleting one node from every graph and not just one graph, and also adding, of course, more XAI methods. Yeah, so that was my presentation. Here are 2 QR codes to our platform and to our preprint, so the paper accompanying the platform. And I want to thank our funding partners and also the GWDG, which is currently hosting our platform. And we are currently doing a usability study for our platform, so we would highly appreciate it if you could take the time to test our platform and yeah, take part in this lovely study of ours. Thank you very much.